All right, thank you so much for joining us today. In this video, we are going to talk about optimization, right? Now, optimization helps us to find the most efficient way of carrying out a task, right? So it might be we want to minimize cost, we want to maximize profit, anything that you want to do that involve cost or maybe time or anything. Optimization is the best, technique that you need to use, right? And anytime you have optimization question, it either goes with constraint that you must met, and then the objective that you need to what maximize or optimize. Good. So let me walk you through how to solve optimization question, and we take examples, and I'll give you trial question to solve. So this is kind of like related rate where we have some steps. The first thing that we need to do is we need to understand the problem, right? So draw some pictures and then we take it from there. You need to also identify your objectives. You need to identify the constraints, right? And then you need to write the objective function. You need to find the domain from the objective function, and then you differentiate the objective function, set the objective function to 0 and solve for the critical values. And then from there, whatever the question is asking you, whether you are finding the dimensions, whether you want to maximize or whether you want to minimize, then you take it from there. So let's take example so that we can basically go through the process and see what we are learning here. So let me read this. A fence is to be built to enclose a rectangular play area alongside the wall of your house. So the clear picture is coming. The wall of the house bounce one side. So as soon as I hear bounce one side, it means that one of the fence is going to be bounded, right? Now suppose we have 500 feet of fencing material. Determine the dimensions of the play area that will enclose the largest area, right? So the first question that I just asked you was what quantity, that is the objective, needs to be optimized, and what condition, that is the constraint, need to be what satisfied. So that is basically what I want to write it down for you. So if we're able to identify your objective and constraint, I think you are good to go, right? So here the objective here is to maximize the area of what the rectangular play, right? So we are going to have something like we want to maximize the area. So from the question is saying that we should maximize the area, right? So we are going to maximize the area of a rectangular, let me see, the play area. And then the constraint, so this is the objective. So I'm just writing the objective here. And then what is the constraint? The constraint here is the total amount of money we are going to use to fence the wall. So total amount of money or total amount of fencing material. Let me put it that way. Good. So this was given to us as even 500 feet. So we are going to use 500 feet. Good. So this is what is giving us. So we have the constraint. The constraint is saying that for us to do that fence, we just need to use 500 feet of fencing material. You cannot go beyond that. So it's like you want to produce something and they've given you something that you need to use to produce it. So that one become a constraint. You cannot go beyond that. Good. So then the objectives is what we want to achieve. We want to maximize what area. Good. Now the idea is that we want to draw some picture here and then we label them, right? So let me just have a picture here. So let me assume that this is this, and let me use red for this. Now the red is the wall of the house. So maybe let me say this is the wall of the house. Now what I'm going to do is I'm going to define my functions. So I'm going to define this one to be x, and then this one will be x, and I'm going to define this one to be y, right? So this is the picture that I need to draw to model this situation. So I'm done with the picture. Now what I need to do is find a function for the quantity that is being optimized and find its domain. So let me even finish something here. Now when we are finding the picture here, you see that from the picture we can do something like the constraint. So for me to fence this, this, and this, we are talking about the parameter here. So when I add this to this to this, it should be equal to this, because the material that we need to use to fence the wall is, or the area is 500. So I'm going to have x plus y plus x, which is equal to 500, and this is going to give me 2x plus y is equal to 500, and I can say that y is equal to 500 minus 2x. So this is kind of the constraint that we need to use, right? Good. Now find a function. We want to find a function for the quantity that is being optimized and find its domain. So what is a function? Remember, we are talking about area, right? So the question is, what is the formula for finding area of a rectangle? So we know that formula for finding area of a rectangle is the width times the length. So we are going to have x times y. But anytime we want to have, let me say, objective function, it should be in terms of only one variable, right? And then we can see from the constraint that y is equal to 500 minus 2x. So we can write this one as area is equal to x 500 minus 2x, because we know that y is equal to 500 minus 2x. And then I can expand this and have something like 500x minus 2x squared. So this becomes the what? The area that we need to optimize. Now we want to find the domain. So for us to find domain, first we are going to assume that x is greater than 0, right? So if x is greater than 0, then what can we do here? We can say that this, we since we are looking at the domain, we are going to make sure that we have this to be greater than something like, let me say, greater than 0, right? So that's basically what we are going to do here. So let me take it from this. I'm going to take the domain from here. So the domain, I have my domain to be, let me say, okay, so let me just do the domain from here. Okay, let me just build the domain from here. So here, if I pick y to be greater than 0, then I'm going to have 500 minus 2x is also greater than 0. Good. So what will be x? So it's going to be 2x is less than 500, and then I'm going to have x to be less than 250. So it means that my domain is going to be something like this: 0 less than let me say x less than 250. Yeah, so this is what I'm going to get from here. So what I'm doing here is basically it's coming from here too as well. So here the area is greater than 0, so it means that 500 x minus 2x squared is greater than 0, and when I factor x out, I have 500 minus 2x is greater than 0, and x should be greater than 0, and 500 minus 2x should be also greater than 0, right? So from here, 500 is less than or is greater than 2x, and x should be less than 250. So when I combine this and this, that's when I get this domain here. So this will be the domain. The domain is going to give us something like this. The domain is going to give us something like this. So this will be the domain that we should be working towards, or in between. So now that we've gotten the domain, let's look at D. Finish the problem. So what we just want to do is let's continue to solve. So here, since we know that A is equal to 500x minus 2x squared, we are going to differentiate it because we need to find a critical value. So this is going to give us 500 minus 4x. And for critical value, a prime of x should be equal to 0. So you are going to have 500 minus 4x is equal to 0. And then 4x is equal to 500. And x should be equal to 125. Good. So that is x. Now that we have x, we know that y is equal to this. So we can find for y. So we know that y is equal to 500 minus 2x. So 500 minus 2 times 125 is going to give us 500 minus 250. And this is going to give us 250. So y is equal to 250. X is also equal to 250. So we need to just finish this. So our final results, the question is saying that we should find the dimension, right? So the dimension is going to be the x and then the y, right? So let me write dimension for largest area is going to be s is equal to 125 and y is equal to 250. So the maximum area will be equal to x times y, which is equal to 125 times 250, and this is going to be 31,250 feet square. So this will be the area or the maximum area that you are going to get. So I just divided this to show you how you can move from this to find the domain. All right, let's take another example and see how we can also go through that question. So when you read the question is saying that a square sheet of cardboard 18 on a side is made into an open box by cutting the squares of equal side out of the corners and folding up the sides. So this is basically what you are doing. So if I have, let me assume that this is my cardboard, right? And then we are going to cut the corners. So the corners is squared. So I'm going to cut this corners here. Now I'm assuming that they are all equal. So I think I need to just clean this. So I'm going to have this something like this. Now we are saying that the size is 18, right? So they are all square, but I think this is not square. Let me just do it this way so that I can get it in this form of square. Okay. So let me pick this guy here. Pick this guy also here. So this from this side to this side is 18, right? And then from this side to this side too is 18. So what I'm going to do is, since we are cutting a square, then it means that this is going to be x, this is also going to be x, right? Same thing applies to this, same thing applies to this, same thing applies to this. So it means that now the distance is going to reduce. Let me see what will be left. So let me see the distance from this side to this side. So the distance from this side to this side is going to be the distance with the green. Now remember, we've taken this x here is the same as the x here, the same x here. So it means that the one with the green is now going to be 18 minus 2x, because I have one x here, one x here. Same thing applies to from this side to also this side. The green is going to be 18 minus 2x. So this is how we can cut the base, right, to form a square. So that is how, that's what we are going to get. So I think I should have brought even the picture down here. Good. But okay, so let me talk about objective. So objective here from the question, objective here, we want to maximize the volume of the open box. Okay, yeah. We want to maximize the volume of the open box. That will be our objective. What is the constraint here? We have a constraint. So looking at the constraint here, so here what we just want to do is we want to, find the size of the cutting out squares that must Yeah, that must such that the size remain positive, right? So basically that will be our constraint here. You will making sure that it's never going to be greater than, let me say, x never going to be greater than 9, something like this, because one of the size is going to be 9 from there. So that is what we are going to get from our constraint from there. Now that we are done with taking the picture, we can think about, talking about the other things, finding the volume and then, going forward. So what's volume of this? What is the volume for this? Now we know that volume is the length times width times what? The height. So here we see that we are going to have the height to be x, right? So the height is going to be x, and then the width and then the length is going to be this and that. So we are going to have 18 minus 2x, 18 minus 2x times x. So this is what you're going to get. Let's try and expand this, and you're having x 18 minus 2x squared. So this is what you're going to get. We can decide to expand it, but we can also leave it in this form. Now, if you want to find domain, then for the domain, we are going to assume that volume is greater than 0 and x 18 minus 2x squared, this is also greater than 0. So here x should be greater than 0. The first x here should be greater than 0. And we are going to pick 18 minus 2x all squared to be greater than 0. And then 18 minus 2x is greater than 0. And then 18 is greater than 2x. And x will be less than 9. So that's basically what you are going to get. So it means that the domain should be 0, s, and 9. Good. So that's what is going to be the domain from here. And let's finish the problem by finding the critical values, right? So it's very important to do that. So now volume is equal to x 18 minus 2x squared. Now, as you know, this is the same as 18 minus 2x, 18 minus 2x. Now, when you expand this, you are going to have 324 minus 72x plus 4x squared. So multiply 18 to 18, you get this. Then 18 times this plus 18 times this. You are going to get minus 72. And then this times this. This is what you are going to get. Multiply through by 8. Multiply through by x. 324x minus 72x squared plus 4x cubed. So this one will help us to find f prime or v prime. So this is going to be 324 minus 2 times 72 is 144x plus 12x squared. So now we can find the critical values from here. So let's do that. So for critical values, we are going to set v prime to be 0. And we are going to have 12x squared minus 4x plus 324 to be equal to 0. So let's solve this and see what we are going to get. Now I can divide this through by 12, and I'm going to have this minus 12x. Is that right? Yes, it's going to be 12x, and this one will be 27. 12 times this will supposed to be giving us that. So now let's try and do the factorization here. We can use 9 and 3, because 3 times 9 is 27, and then minus 3 minus 9 is going to give us that. So we can use minus 3x squared minus 9x plus 27 is equal to 0. So with the red, I factor s out and I have x minus 3. With the blue, I factor minus 9 out and I have x minus 3 again. So I'm going to have x minus 3, x minus 9 is equal to 0. So this one is good for us to see that this is equal to 0, x should be equal to 3, x minus 9 is equal to 0, and x should be equal to 9. So we are getting two of them, 3 and 9. But For us to choose which one is the critical value, we need to check the domain. Now we saw that the domain, the x should be lying between 0 and 9. 9 is not included. So here we are going to choose the critical value to be x is equal to 3 only, without the 9, because 9 is not inside the domain. So that's what you are going to do. So now that you've gotten the x, which is the critical value, and it's inside the domain, we need to find for the corresponding value, right? So what will be the corresponding value? So the corresponding value will be picking this one. We saw 18 minus 2x, right? So let me say this is the length, which will give us the other side. So we are going to have this one to be 18 minus 2 times 3, which is going to give us 18 minus 6, and this is going to give us 12. Good. And then yeah, so we are having the length to be 12, width to be 12, and the height, which was x, is 3. So we had the height, which is this, is 3. So these are the dimensions that we are having here. And since we are having the dimension, L is equal to 12, W is equal to 12, and H is equal to 3, then we can find the volume. So volume is L times W times H, and we have 12 times 12 times 3, and this is going to give us 12 times 12 is 144 times 3, should be giving us 432. Good. So this is what you are going to get for finding the volume. Good. Finding the volume. Let's take last two questions, and then I'll give you trial questions to solve, right? So this one too is a cylinder, and we want to solve it, right? So let's try and figure it out. Now here, the first thing that we need to understand is, if we don't know the formula for finding the surface area, we are going to suffer a lot from here. So the first question that we need to do is, what's the volume? What's the volume for finding cylinder, right? So the volume of a cylinder is pi r square h, right? And then they've given us that. So a cylindrical can is to hold 1 liter, which is this, centimeters of oil. Fine. So this is like the volume that the cylinder can hold. So this is the volume. So now I can say that pi r squared is equal to 1000, because we are talking about the volume here. Now we want to find a dimension that will minimize the surface area, and that's the cost to build that can. So basically, now that we know this, now let's talk about the surface area too. What's the formula for finding the surface area? So surface area is 2 pi r squared plus 2 pi rh. So this is the formula for finding the surface area of a cylinder. So this is what you are getting here. So now let's try and solve some of the things, and then we just plug them inside, and then we just go. So what we are going to do here is, here we can make one of the variable the subject here. So this one is good for us to make h the subject. So let's make h the subject here. So h is equal to 1000 divided by pi r squared. Now don't forget, the variables that we are dealing with is h, which is the height, and r, which is the radius, right? So now we can plug in h inside this, so that this one will be in terms of only one variable. Now let me name this one S to be the surface area. So I'm going to have 2 pi r squared plus 2 pi r times h, which is 1000 pi r squared. So let's do that. Multiply this, and you are going to have 2 pi r squared plus pi will cancel, one of the r2 will cancel, so I'm going to have 2000 divided by r. No, yes, just r. So this is what I'm going to get. And since I'm getting this one, you can see that this is in terms of only r, so I can write this one as s of r, meaning that now if I want to get the critical values, I'm going to differentiate this with respect to what? R. So let's do that. S prime is going to be, when I differentiate this, I'm going to have 4 pi r, because now I'm differentiating with respect to r. So 2 drops down, subtract 1, and this one will be left with 1. Now 1 over r is the same as this. So when I differentiate this, I'm going to have minus r minus 2, because I need to subtract 1 and multiply by minus 1 here. So this is going to give us minus 2000 divided by r squared, because this is the same as minus 1 over r squared. So when I multiply it by this, and I get this. So this is s prime. So what we need to do is we need to find the critical value. But for us to do that, we need to simplify this. So this is basically divided by 1. So this times this minus this times this divided by this times that. So this is going to give us 4 pi r cubed minus 2000 divided by r squared, right? So first rule, this times this will give us this. Then the 1 which is divided by this will multiply this, which is this, and the 1 times this will be this. So now for critical values, we can set SR to 0, and we are going to have 4 r cubed minus 2000 divided by r squared to be 0. So as I said, anytime you have this, you need to set r, the denominator, to 0. So r should be 0. And then the top, we set the top to 0. 2000 is equal to 0. So 4 pi r cubed is equal to 2000. Then what are we going to get? R cubed is equal to 2000 divided by 4 pi. And then r will be equal to the cubic root of 2000 divided by 4 pi. Now let's check which one are we going to use. Remember, if we want to find the domain from here, the domain, we are not going to include r is equal to 0, because anytime r is equal to 0, the domain will be what? From here, even from here. Anytime r is equal to 0, we are not going to have the domain to be, the domain is going to be undefined. The function is going to be undefined whenever we have r to be 0. So we are going to choose this to be the r, right? And let me just approximate this to, let's say, 5.3, right? So if r is equal to this, then I can find for h, because I know that h is 2000 divided by pi r squared. Is that right? Yes. So it's from here. 1000 rather. So let me just write 1000. So this is going to be 1000 pi times 5.43 squared, and this is going to give us 10.8 centimeters. So this is the radius and this is the height. So now if we want to find the cost, then we just plug in our h and then our r inside the surface area here. And then if you want to know the volume, when you plug it inside this one, it's gonna give you something approximately to 1000. So the dimension, we want to find the dimension. So this is the dimension, radius and h, and then the surface area is when you plug in those values inside this one, then you are done. All right, so this is the last question that we are going to solve. Try this question and leave your final results in the comment section. So in the next video, we are going to take a quiz question and then we solve them together. Now, in the next 2 videos, we are going to talk about integration, right? From there. See you in the next video.